In question 1, we are told that the first three terms in the expansion of 1 plus kx to the power of 16 are 1, negative 4x, and px squared. And we need to find k and p. I will actually start by writing out the first few terms in the expansion of 1 plus kx to the power of 16. So we start with the full power loaded onto 1, and then it's 16, choose 1 to the power of 15 times kx, plus 16, choose 2, 1 to the power of 14 times kx all squared, plus 16, choose 3, 1 to the power of 13, kx all cubed, plus dot dot dot. And then I will simplify this to give me 1 plus 16kx plus 120k squared x squared plus 560k cubed x cubed. And we have been told that this is 1 minus 4x plus px squared plus dot dot dot. So I could equate the x term, so the 16kx with the minus 4x, and also the 120k squared x squared with the px squared. So we know that 16k should be negative 4, so k turns out to be minus 1 over 4, and then in II, we've got that 120k squared is equal to p. So 120 times minus a quarter squared is p, which means that p is 15 over 2. In part B, we are told that g of x is 2 plus 16 over x times 1 plus kx to the power of 16, and we need to find the term in x squared using the value of k we have found in part A. So I will actually start by writing that g of x is 2 plus 16 over x times 1 plus kx to the power of 16. I will use my expansion for the 1 plus kx to the power of 16. It's 1 minus 4x plus 15 over 2x squared plus 560k cubed x cubed plus dot dot dot. And so the term in x squared will arise from the multiplication of the constant with x squared and the over x with the x cubed term. So these are the two combinations that will contribute towards the x squared term. So this will be 2 times 15 over 2x squared plus 16 over x times 560k cubed x cubed. We know that k was minus a quarter. I will substitute this in, so it's 15x squared plus 16 times 560 times minus a quarter cubed times x squared plus dot dot dot. The x cubed with the x gave me the x squared. So this is 15x squared minus 140x squared. So we can see that this will give overall a minus 125x squared. So we need to state now that the term in x squared is minus 125x squared. In question 2, a sequence is defined by the first term being 6 and the next term being k times the previous term plus 3. This is a recurrence relationship. We need to find, in terms of k, an expression for u3. So I will actually start by saying that u2 is k times u1 plus 3. So it's going to be 6k plus 3. And then u3 is k times u2 plus 3, which is k times 6k plus 3 close brackets plus 3. So it's going to be 6k squared plus 3k plus 3. And then in B, we are told that the sum of the first three terms is 117, and we need to find the value of k. So I will actually start by stating that we have been told that u1 plus u2 plus u3 is 117. Now u1 is 6, u2 was found to be 6k plus 3, and u3 is 6k squared plus 3k plus 3, and all of these added up gives me 117. I will collect everything on the left hand side. I get 6k squared plus 9k minus 105 is 0. I will divide everything by 3 to get 2k squared plus 3k minus 35 is 0, which factorizes into 2k minus 7 times k plus 5, which gives rise to two possible values for k. Either 2k minus 7 is 0 or k plus 5 is 0. So we have at the moment that k could be 7 over 2 or k could be negative 5. However, if we look at the question, we were told that k is a positive constant, so I will reject the k is negative 5 since k is positive. In question 3, we've been given the graph of log x base 10, and we need to use a trapezium rule, it says, with 4 strips of equal width in order to show that the shaded area R is approximately 10.10. So I will actually start by creating a table that goes for x from 2 up to 14. We need to split this into 4 equal strips. So from 2 up to 14, we've got a width of 12. If I split this into 4 equal parts, it means I've got strips of width 3. So it's going to be 2, 5, 8, 11, 14. And then my y values, which is the log of x base 10, will be log of 2, log of 5, log of 8, log of 11, and log of 14. So the area R will be approximately a half times the width of the trapezia, which is 3 here, the difference between two consecutive values of x. So a half times 3, and then the first and last y values are included once, and all intermediate values are included twice. So 2 times log 5 plus log 8 plus log 11, close the brackets. This gives an answer of 10.101095 ... which rounds to 10.10 to 2 dps as required. And then in B, we are taught to explain how this trapezium rule could be used to obtain a more accurate estimate for the area of R. So we know that the more strips we use, the more accurately we follow the curve and the more accurate our estimate will be. So the answer is simply to use more strips. And then in C, we have to use our answer to part A in order to estimate the integral of log of root x and log of 100x cubed. So I will actually start by writing out the integral I've been given in I. So it's from 2 to 14 log of root x base 10 dx. This can be written as log of x to the half base 10. And I know that the half can come down. So from 2 to 14, a half log x base 10 dx. So this will be a half times the integral from 2 to 14 of log x base 10, which is what we have estimated just a while ago. So it's approximately a half times 10.101095. I'm using the full accuracy here. So this is 5.05. And then in II, it's the integral from 2 to 14 of log of 100x cubed base 10. So I will start by expressing the product as a sum of logarithms. So it's log of 100 base 10 plus log of x cubed base 10 dx. So this is from 2 to 14, where the log of 100 base 10 is simply 2 because 10 squared is 100. The 3 can come down, plus 3 log of x base 10 dx. So this will be 2x from 2 to 14 plus 3 times the integral from 2 to 14 of log of x base 10 dx. So I will substitute the upper and the lower limits. 2 times 14 minus 2 times 2 plus 3 times the answer we had from the trapezium rule. So once more I'm using full accuracy, and this leads to an answer of 54.30. In question 4, we are given f of x here, and we are told to state the value of the remainder when f of x is divided by 2x minus 3. This is only worth a mark. The prompt to state indicates that it's a simple thing to do. It should be straightforward, no calculations needed. So if I divide the f of x by 2x minus 3, I know that this part divides exactly, so it will leave a remainder of 0, and I'm left with the negative 21. So this will simply be minus 21. That's the remainder when I divide by 2x minus 3. And then B, use the factor theorem to show that x minus 3 is a factor. So if x minus 3 is a factor, it means I need to evaluate f of 3, and I expect this to give me an answer of 0. Let's see. So f of 3 is 3 squared minus 2 in brackets times 2 times 3 minus 21. This is 7 times 3 minus 21, which is 0. We need a conclusion here. Therefore, x minus 3 is a factor. This is for 2 marks. The conclusion here will give you the second mark. Hence, it says factorize f of x and show that f of x has only one real root. So I will actually start by writing out what f of x is. F of x is x squared minus 2 times 2x minus 3 minus 21. I will expand this into 2x cubed minus 3x squared minus 4x plus 6 minus 21. So it's 2x cubed minus 3x squared minus 4x minus 15. Knowing that x minus 3 is a factor means I can do long division now. So 2x cubed minus 3x squared minus 4x minus 15 will be divided by x minus 3. We are always trying to match the highest order term here. So I will multiply by 2x squared. So 2x cubed minus 6x squared. I subtract. I get 3x squared minus 4x minus 15. So plus 3x now to give me 3x squared minus 9x. Once again I subtract. I get 5x minus 15. So we want the plus 5 now. So this is 5x minus 15. So divides exactly, it leaves a remainder of 0. So at the moment, we've got that f of x is x minus 3 times 2x squared plus 3x plus 5, which is the factorization of f of x, the first part. And then to show that f of x has only one real root, we could say that f of x is 0 means that either x minus 3 is 0, so x is 3, or 2x squared plus 3x plus 5 is 0. Now, knowing that we're only looking for one real root and we already found x to be 3 to be that root, then this means that this quadratic here should not be giving you any real roots. So immediately I'm thinking of considering the discriminant. The discriminant is b squared minus 4ac, which gives an answer of negative 31, which is less than 0. Therefore, no real roots on this part, and hence I can conclude that f of x has only one real root. Whenever you're doing the discriminant, remember you need to explicitly compare with 0 in order to conclude that you have no solutions, so that you justify your conclusion. In question 5, we are being told that a company has extracted 480 tons in year 1, then 465, then 450, so we're forming an arithmetic sequence. So we are being told to find the mass of silver extracted in year 14. It is obvious that we're looking at an arithmetic sequence with first term being 480, common difference being minus 15 because I keep dropping by 15. So in the 14th here, that will be the 14th term of this sequence. So it's gonna be A plus n minus 1 D, which gives an answer of 285 tons. And then after a total of 7,770 tons has been extracted, we've stopped mining. Given that this occurred at the end of year capital N, show that capital N satisfies this quadratic here. So what we have here is that the summation of the first n years gave a result of 7,770. We know the formula is n over 2, 2a plus n minus 1 d, and this is 7770. Notice I'm using capital N, not small n, because the question is asking for the value of capital N. So this means that capital N over 2 times 960 minus 15n plus 15 is 7,770. So I will proceed in expanding this, so the 2 will be cross multiplied. In the bracket I've got 975 minus 15n. On the right hand side I've got 15,540. So further expansion will give me 975n minus 15n squared is 15,540. I could collect everything on one side, so 0 is 15n squared minus 975n plus 15,540. So if I divide throughout by 15, I get n squared minus 65n plus 1,036 as required. That was the first part. And then for C, we need to solve and find the value of n. So we can factorize this into n minus 37 times n minus 28. Now, if we cannot see the factors, we can go for the quadratic formula and show the method. This means that n is 37 or n is 28. We obviously have to choose the smallest of the two values of n. That's the quickest that this amount will be mined. So we have to say hence capital N is 28. Question 6, we've got a circle. The question is given here. We need to find the coordinates of the center of this circle. So I will actually complete the square. We have that x squared plus 10x plus y squared minus 12y is equal to k. So if I complete the square, I get x plus 5 squared minus 5 squared plus y minus 6 squared minus 6 squared is k. So x plus 5 all squared plus y minus 6 all squared is equal to k plus 61. Now, from this, we can conclude that the coordinates of the center are minus 5, 6. This can be seen from the brackets here. And the radius will be the square root of k plus 61. And therefore, it is obvious that we need k plus 61 to be greater than 0. Otherwise, we will have a problem in evaluating the square root if it's negative. So this means that we need k to be greater than negative 61. In II, this is an independent part now. We've got that the point P0, the point Q, negative 210, the point R, 8, negative 14 are on a different circle. We are told that QR is the diameter of C2 and P is a positive constant, and we need to find the value of P. It actually makes sense to draw a diagram quickly here just to have a graphical appreciation of what's happening. So this is a circle here. We are told that QR is a diameter, so this is Q, this is R. R has coordinates 8, negative 14. Q has coordinates negative 2, 10. And P is somewhere with coordinates P0. We know that since the QR is a diameter, the QPR angle should be a right angle, should be 90 degrees. So I will actually consider gradients. The gradient of PQ is 0 minus 10 over P minus minus 2. And this is minus 10 over P plus 2. The gradient of PR is 0 minus negative 14 over P minus 8. So it's 14 over P minus 8. And we know that the product of these two, the gradient of PQ times the gradient of PR should be negative 1. So minus 10 over P plus 2 times 14 over P minus 8 should be negative 1. This means that minus 140 over P plus 2 P minus 8 should be negative 1. The minus with the minus give me plus. So I will cross multiply to get 140 is P plus 2 times P minus 8. I will expand the right hand side to give me P squared minus 8P plus 2P minus 16, and collect everything on the right hand side. P squared minus 6P minus 156. And then I will use the quadratic formula here. P is minus negative 6 plus minus negative 6 squared minus 4AC square rooted over 2 times the coefficient of P squared, which is 1. This is giving me answers of 3 plus minus 165. However, we have been told that P is a positive constant, so since P is greater than 0, we have that P must be 3 plus the square root of 165. That's the exact value for P. In question 7, we start off by being told that a geometric sequence has first term 4 and common ratio 6, and we have to find the minimum possible value of n if we are told that the nth term is greater than 10 to the 100. So we will start by writing out that we have been told that the first term is 4, the common ratio is 6, and we need to solve un is greater than 10 to the 100. So the nth term is ar to the n minus 1. So I will take logs of both sides. So log of 4 times 6 to the n minus 1 is greater than log of 10 to the 100. So the log of the product is the sum of the logs. So log 4 plus log of 6 to the n minus 1 is greater than 100, because log of 10 to the 100 is simply 100. Now this means that log 4 plus n minus 1 log 6 must be greater than 100. So n minus 1 log of 6 is greater than 100 minus log of 4. So n minus 1 is greater than 100 minus log 4 over log 6. And therefore n is greater than 100 minus log 4 over log 6 plus 1, which means that n is greater than, if you put it on the calculator, 128.736. Bearing in mind that n has to be an integer, we conclude that the first solution will be 129. And then in II, we've got a different geometric sequence. We are told that the second term is -6. The sum to infinity is 25. We need to show that R, the common ratio, satisfies this quadratic here. So let's write what we have been told. We have been told that the second term is -6, which is A times R. The sum to infinity is 25, and this is A over 1 minus R. So I could actually say that -6 over R is equal to A, and 25 times 1 minus R is 8. So we are essentially looking at simultaneous equations. Now, -6 over R is equal to 25 times 1 minus R. I have equated the two. So -6 over R is 25 minus 25R. I will cross multiply to get 25R minus 25R squared. So 25R squared minus 25R minus 6 is 0 as required. That was the A part here. And then we need to write down the solutions. So this factorizes, or you could use your calculator. It factorizes into 5R plus 1 and 5R minus 6 is 0. So R is minus 1 over 5, or R is 6 over 5. So these are the solutions to the given quadratic, this quadratic here. And we are told to state the value of R, giving the reason for our answer. Well, we have been told that the sum to infinity exists, so the sequence is convergent. If it's convergent, it means that the common ratio is between -1 and 1. So this simply means that each subsequent term is smaller in absolute size. So we have to say that R is -1 over 5. Since for the sequence to be convergent, we need R to be between -1 and 1. And then find the sum of the first 4 terms. So we need to find S of 4. This is A 1 minus R to the n over 1 minus R. Well, we could try finding A and all of that. However, if we are a bit observant, we see that A over 1 minus R is simply the sum to infinity, which we have been told to be 25. So this is 25 times 1 minus a fifth to the power of 4. And this gives an answer of 624 over 25. In question 8, we are given a sketch of part of the curve C with this equation here. We are told that M is a maximum turning point, and we're also told that the x-coordinate of M is 2, and we need to show that K is 28. So we will actually start by differentiating. We know that at the turning point dy dx must be 0. So dy dx here will be 4/3 times 3x squared minus 22x plus k. This simplifies to 4x squared minus 22x plus k. And we know that if we evaluate dy dx at x is 2, so we substitute x with 2, we get 4 times 2 squared minus 22 times 2 plus k. And this should be 0 because it's a turning point. So 16 minus 44 plus k is 0, which leads to k being 28 as required. And then in part B, determine the range of values of x for which y is increasing. So if we look at the graph here, increasing means that as I draw from left to right, my pencil goes up. So up to here, and then from this point onwards. So the derivative should be greater than or equal to 0. It's gonna be up to the maximum, and then from the minimum and onwards. So I will actually start by saying that increasing means that dy dx is greater than or equal to 0. And this will lead to a quadratic inequality that we need to solve. So we've got 4x squared minus 22x plus 28, the value of k we just found, greater than or equal to 0. I will divide everything by 2 to get 2x squared minus 11x plus 14 is greater than or equal to 0. And this factorizes into x minus 2 brackets 2x minus 7. We know that the critical values here are 2 and 7/2. So if I quickly draw a smiley parabola here, this will have cuts at 2 and 7/2. We go plus, minus, plus, and we want to be positive. So we can say that it's all values of x such that x is less than or equal to 2, or so union all values of x such that x is greater than or equal to 7/2. So that was part B. And then in C, we've got that L passes through M parallel to the x-axis, and we need to find the exact area of the shaded region R, this area here. So the idea is for me to actually find the equation of the straight line. Well, I know that the x value of M is 2, so I will substitute in the expression for y to get the y value here, and then I will proceed with algebraic integration. So I start by saying that when x is 2, y is 4/3 times 2 cubed minus 11 times 2 plus 22 times 2, which gives a value of 68/3. So if I quickly go back to my diagram, this is the line y is 68/3. I see that the region R here is bounded above by the straight line and from below by the curve. So I will integrate from 0 up to 2, the 2 being the endpoint here, the line above 68/3 minus the curve below, which was the y from here, with respect to x always. This will give me the shaded area R. So R will be the integral from 0 to 2, 68/3 minus 4/3 x cubed minus 11x squared plus 28x dx. So I will simplify this. It's gonna give me 68/3 minus 4 over 3x cubed plus 11x squared minus 28x dx. I will increase the power by 1, divide by the new power, so 68 over 3x minus 4x to the power of 4 over 12 plus 11x cubed over 3 minus 28x squared over 2 from 0 up to 2. There are some simplifications I could carry out, so it's a 68 over 3x minus x to the power of 4 over 3 plus 11x cubed over 3 minus 14x squared, with the limits being 0 and 2 as we already said. So I substitute the upper limit, it's 68 over 3 times 2 minus 2 to the power of 4 over 3 plus 11 times 2 cubed over 3 minus 14 times 2 squared. And we notice that upon substituting x is 0, all of these will give me a result of 0. So the lower limit will contribute 0 to this. And then we have that plugging everything on the calculator gives me 40 over 3 square units. Question 9, it's a proof question. We need to prove that for all positive values of x and y, we've got this inequality holding true. I don't really have a starting point, so I will start from what I need to prove to be true. So I say x plus y over 2 is greater than or equal to the square root of xy. I could square everything, so x plus y over 2 all squared is greater than or equal to xy. I expand the left, x squared plus 2xy plus y squared over 4 is greater than or equal to xy. So x squared plus 2xy plus y squared is greater than or equal to 4xy. I could collect everything on one side here, and this will give me x squared minus 2xy plus y squared being greater than or equal to 0, which I realize it's a perfect square. It's x minus y all squared, which is greater than or equal to 0. So this is actually providing me with the starting point for the proof. All of this is an investigation to find the starting point. So these are called jottings. They are not a solid mathematical proof. Instead, the proof begins now by saying x minus y all squared is greater than or equal to 0. And essentially what will happen here is that I will be going from the last step towards the first one at the beginning. So if I expand, I get x squared minus 2xy plus y squared is greater than or equal to 0. So I could add 4xy to either side of the inequality, leading to x squared plus 2xy plus y squared is greater than or equal to 4xy. The left-hand side is x plus y all squared greater than or equal to 4xy. So I could now take the square root of both sides. So x plus y is greater than or equal to the square root of 4xy. I need to say here that since x is greater than 0 and y is greater than 0, because both of them are positive, the square root of x plus y all squared is simply x plus y. So this gives me x plus y greater than or equal to 2 root xy as required almost. If I divide by 2, I get exactly what I had to show. So x plus y over 2 is greater than or equal to the root of xy as required. And then in part B, I need to prove by counterexample that the inequality does not hold when x and y are both negative. So what I could do here is say I will pick x is minus 1 and y is minus 1. So consider x is negative 1 and y is negative 1. Then x plus y over 2 is simply negative 1 plus negative 1 over 2, which is negative 1. and the root of xy will be -1 times -1 all square root, which is the square root of 1, which is 1. And this means that x plus y over 2 is less than the root of xy, hence statement is false. Question 10 is a trigonometry question. We've got the first one. Solve x is in radians between -pi/2 and pi/2. Tan squared of 2x plus pi/4 is 3. So we can start by saying, okay, we've got tan squared of 2x plus pi/4 is 3. The first thing to do is say this gives me tan of 2x plus pi/4 is root 3, or tan of 2x plus pi/4 is negative root 3. My principal value is shift tan of root 3, which is pi/3, and for the other equation is shift tan of minus root 3, which is minus pi/3. This means that for the first equation, we've got 2x plus pi/4 is pi/3 plus pi k. So 2x, I'll do pi/3 minus pi/4, which is pi/12 plus pi/k. And then I'll divide everything by 2 to get x is pi/24 plus pi k/2. And for the second equation, I've got 2x plus pi/4 is negative pi/3 plus pi k. So 2x is minus 7 pi/12 plus pi k, which means that x is minus 7 pi/24 plus pi k/2. I am now ready to start generating solutions for x between -pi/2 and pi/2. If I put k to be 0, I get pi/24 and then -7 pi/24. If I put k to be -1 here, I will get minus 11 pi/24. And if I put k to be 1 in the second equation, I'll get 5 pi/24. There's a total of 4 solutions within the required range. And then in II, we're being asked to solve this equation here. Answers to be given to 1 decimal place. We are in degrees between 0 and 360. I will actually start by writing the equation I was given. 2 sine theta minus cos theta all squared is 1. I could expand this to get 4 sine squared theta minus 4 sine theta cos theta plus cos squared theta is 1. This means that 4 sine squared theta minus 4 sine theta cos theta is 1 minus cos squared theta. So 4 sine squared theta minus 4 sine theta cos theta is sine squared theta. I will collect everything on the left hand side, which gives me 3 sine squared theta minus 4 sine theta cos theta is 0. I'll factor out the sine theta, so it's sine theta, 3 sine theta minus 4 cos theta. So I have that sine of theta is 0, or 3 sine theta minus 4 cos theta is 0. So this means that 3 sine theta is 4 cos theta. I could divide both sides by cos theta in order to recover a tan theta on the left hand side. So this means that 3 tan theta is 4. So tan theta is 4/3. And I'm now ready to solve the given trigonometric equations. For sine of theta is 0, the principal value is shift sine of 0, which is just 0. So theta is 0 plus 360k, or theta is 180 minus 0 plus 360k. Whereas for tan theta is 4 over 3, my principal value is shift tan of 4 over 3, which is 53.130. So theta is 53.130 plus 180k. So between 0 and 360, I get values of 53.1, I get 180, and I get 233.1. In case you are wondering, 0 and 360 are also solutions. However, we are strictly between 0 and 360, so these need not appear in the solution set for theta.